I will be explaining Brook's theorem in this video. Okay, so you can see the statement in a very simple manner. Okay, when you look at the textbook or some other notes, you feel difficult and you feel helpless. You feel, oh my god, how I am going to learn this theorem. These things will run in your mind. Okay, but this video will help you to write this proof in your examination paper. Okay, so this will help you to feel easy to learn the proof of this theorem. I believe that. Okay, let's start studying this proof. Okay, before that, let's read the statement of this theorem. If G is a connected symbol graph, that is, they are given you a graph. Okay, imagine a graph and they are saying this graph is a connected graph and it is a symbol graph. You have to know what is connected, what is symbol graph, right? When I say these things, the definition of connected graph, symbol graph should come into your mind. Okay, if it is not coming, then you have to work on it. You have to try to know about it. Connected graph means what? The graph will be connected. Okay, a symbol graph means what? There will be no loops. The graph should not have loops and the graph should not have what? Multiple edges. Okay, and that kind of graph you are having, and is neither an odd cycle. Okay, if G is a connected simple graph and is neither an odd cycle, that is, this G is not an odd cycle and nor a complete graph. Also, they are saying this G is not a complete graph also. Then, if a G is having these properties, then chi less than or equal to delta. This is what we have to prove. Chi means chromatic number of a graph. Chromatic number means what? You will color the graph with the minimum colors. Okay, that is called chromatic number usually. So here you have to prove chi less than or equal to delta. Delta means maximum degree of that graph. Is that clear? Okay, this is what we have to prove. Whenever you see this question, state and prove Brook's theorem in the question paper, immediately the statement should come into your mind. First, bring a graph in your mind and you have to say this graph is what? Connected and a symbol graph. Also, what? This graph is neither an odd cycle nor a complete graph. Then you have to prove this. Okay, let's start proving the proof of this theorem. Let's start proving this theorem. First, let G be a k-chromatic graph which satisfies the hypothesis of the theorem. This is what the first line you have to write. It means you are taking a graph G and this graph G is a k-chromatic graph. It means what? Using k colors, k is the minimum color. Okay, that using minimum color, that is k. The number of colors you used in the minimum to color that graph, that is k. Okay, so that is why you are saying this G is a k-chromatic graph and you are taking this G is satisfying all the conditions of the theorem. Like that you are taking a graph G. This G is what? K-chromatic graph. Without loss of generality, also you are assuming that G is k-critical. You know that if k-chromatic means, by the definition of k-chromatic, this k-chromatic graph will be k-critical also. Okay, there is a definition. I will show you afterwards. Okay, so here by that definition you are assuming, okay, using that you are assuming G is k-critical. Now you have a theorem that every critical graph, now you have said this G is what? G is k-critical. You are assuming like that, no? So from a theorem you know that every critical graph is a block. Okay, this statement they may ask you for the 1 mark question. Okay, in a previous year question papers I saw this question. So every critical graph is what? Block. You are using that sentence here. Okay, so we have, can you see that? Every critical graph is a block. Therefore, here you can say our G is a block. That is what you are writing. Now also, since one critical, you are having already you are having some of the results about one critical graph, two critical graph and three critical graph. Okay, so you are writing about it. Since one critical and two critical graphs are complete, one critical graph and two critical graphs will be complete. Okay, and from a problem you are saying this, three critical graph are odd cycles. Okay, these are the already proved results. Okay, so you are writing those things here in our proof. One critical graph and two critical graphs are what? Complete. Three critical graph is what? Having odd cycles. No, so till 3 you know that, right? So here you are taking here you are talking about k critical, k critical, k critical. No, so you are taking, we have the value of k as k greater than or equal to 4, because till 3 critical you know something. Okay, after 3 you don't know anything, right? That is why here you are taking the value of k as k greater than or equal to 4. We have k greater than or equal to 4. Now, if our G has a 2 vertex cut UV, it means our graph is having 2 vertex cut. Vertex cut means what? In a graph, you will have 2 vertices, U and V, okay? This U and V are the vertex cuts. It means when you remove this vertex U from that graph, the graph will be disconnected. Also, when you, it is not necessary to remove these 2 vertices at the same time, okay? It is not necessary. When you take a vertex U from that graph, the graph will be disconnected, and when you take the vertex V from that graph, the graph will be disconnected. So these two are called what? Vertex cuts. So that is why if G has 2 vertex cut, these two, then by a corollary you will get this result. Write it. D of U plus D of V greater than or equal to 3k minus 5. But delta greater than or equal to degree of U, delta greater than or equal to degree of U. This is you know, because delta means, as I told you, it's a maximum degree. Maximum degree will be greater than or equal to degree of U. Okay, degree U means what? One vertex from that graph. No, so degree of that U will be less than the maximum degree. Okay, that's what delta greater than or equal to degree of U and delta greater than or equal to degree of V. Now, 2 delta is equal to, you are adding, okay, you are adding. When you add this, you will get 2 delta greater than or equal to D of U plus D of V. From this, you will get, you know, that D of U plus D of V value. So substitute this here, and this value will be greater than or equal to 2k minus 1. This value will be greater than or equal to 2k minus 1. For our convenience, you are writing, okay. So this value surely will be greater than or equal to this value. Wait a minute. Yeah, this value greater than or equal to this value. You are writing. Now what you are doing is, the next step, you will take 2 common from here. 2 common from here, okay. When you take 2 common, so and the 2 you have took as a common will get cancelled in both sides, and you will get this. And from this you will write delta greater than or equal to k. K will be equal to chi. The reason is because G is k critical, no. K critical means k critical. So k critical means what? K means what? Minimum color used. Minimum color used can be denoted as what? Chi. Okay. So that is why using all these things, they are okay. From all these things, they are saying delta greater than or equal to k. K will be equal to chi. Okay. K critical means k colors they are using. Minimum number of color is k. That k number of colors they are using to color the graph. Chi means what? Chi means also minimum colors used to color the graph. So you can put k equal to chi, no. So that is what you are writing. So from this you can get chi less than or equal to delta. You proved it. In notes, in book, there is case 2 also. I am not interested to write case 2 here, because I proved it, no? So I am stopping here. In examination also I will write till this only. Okay. Thank you.